Hello and welcome. I'm Dom Hale for Australia's Mining Monthly and Mining Magazine. I'm here today with Gary Poxleitner, Principal Mining Engineer at SRK Consulting. SRK provides focused advice and solutions to clients in the earth and water resource industries. Now, today, Gary is going to be discussing how mining operations can overcome underground haulage bottlenecks through emerging technologies, infrastructure integration, and smarter, more sustainable material transport solutions. Gary, it's great to have you here today.
Fantastic. Great to meet you as well. Thanks for having me.
Pleasure. Gary, let me start by asking how SRK is helping clients overcome those operational bottlenecks in underground material transport, especially in deep level mines.
Yeah, so as you know, that mining is basically a material movement exercise. So besides fragmentation, we want to move material from one point to the other. And we want to streamline that as much as possible. And as mines get deeper, we create these multiple material handling systems, be it shaft, conveyor, haulage. And what we look at is we step back and we look at the big picture, and we're trying to streamline that as much as possible, identify bottlenecks with discrete simulations sometimes, and mitigate them with a more streamlined process.
So staying with that focus on operational innovation, can you highlight some specific examples where SRK has advised on implementing battery electric or autonomous haulage systems underground?
Yes, of course. So there's a number of examples where SRK takes a look at conventional material movement exercises or conventional material movement systems like diesel truck, for example, which is very common in-ground into our industry currently. SRK has been involved with doing trade-off studies to take a look at the current fleet system, be it diesel, and compare that to a battery electric or trolley system, and completing trade-off studies and showing that one system may have a benefit over the other system, and making a suggestion on what the preferred material movement system would be and the advantages of that.
Now, thinking about how those technologies actually fit into working mines, what are the key technical considerations when integrating new material transport technologies into existing underground infrastructure?
Yeah, within your question, you make a valid point. If it's a greenfields or a new potential operation, it's not as challenging to implement new technologies because we're obviously starting from scratch. But in an existing or brownfield operation, there are three considerations. One is culture. You're bringing in a new idea or a new method that the mine isn't familiar with. The second is there actually a benefit to the mine operation in the form of material movement and a cost benefit? And third is, how is this new technology going to affect the current operation in the movement of material? And we would approach these, all three of them, in a similar way. The first is a culture, introducing the technology and showing them that it can work, that it has worked. I mean, we've brought people to different site visits and showing them where a new innovative technology exists and works effectively. The second is to show that there is a cost benefit and a safety benefit and a material movement benefit with this new technology through trade-off studies, using the existing system as a base case and evaluating different innovative technologies compared to that base case and demonstrating that it is a benefit to the mine. And the third is implementation. So it does disrupt a brownfield's current operating mine to bring in a new material movement technology, but we can mitigate them by planning ahead, doing management of change to mitigate any safety or risks that might be there. We can work off shift to construct and do cutouts for charging stations, for example.
Great stuff. Well, look, once any new systems are up and running, the way they're monitored and managed becomes critical. So how are digital connectivity and real-time data analytics transforming fleet management and ore transport efficiency in those underground operations?
Yeah, so as you know, in mines, we have generally a lot of data. available to us, but we don't always use that data in a practical sort of way. It kind of sits there. We're good at collecting it, but how do we turn that data into something of use? And what digitization can do is it can take a look at your fleet management, and it can identify areas where, for example, an LHD is mucking a drop point in a sublocative block caving, and maybe it's not as effective there, and identify another location and say to the LHD, go over there and muck there because it's more efficient. Or another thing is, if a truck is releasing diesel particulates, for example, the digitization can pick up on that diesel particulate matter and inject a higher ventilation volume. So that's the future of mining.
And another major factor influencing decision making today is, of course, sustainability. In your consulting experience, how are sustainability goals influencing the choice of material movement technologies underground?
Yeah, I mean, we have to consider sustainability in everything we do. The fact is, more and more investors are looking at mines that are sustainable, that show and demonstrate responsible mining. And I mean, there's technologies out there that used in the civil application, battery electrical vehicles, wind turbines, solar, that that we say are very responsible. But we have to go back to the source. People are asking, okay, the metals that are being used here, are those mines sustainable? Are they mining responsibly? So there's a lot of interest for mining as well to show and demonstrate that it's becoming more and more sustainable, not just for the mine, but also for the end user.
Understood. So finally then, Gary, looking further ahead and thinking more broadly about innovation from SRK's perspective, which emerging technologies or innovations hold the most promise for improving deep underground material flow, perhaps in the next 5 years?
Yeah, so we've already talked about the importance of streamlining material movement systems, and that's a big cost. Uh, every time we create one material handling system and another material handling system, another one, we create bottlenecks in between each of those material handling systems. And every time we pick up ore or rock and drop it in, it's another $5 a ton that it's going to cost you. So it's high cost not to have a streamlined, efficient system. So we need to step back and say, okay, with this current material movement system from point A to surface, from the stope to the mill, how can we streamline this? How can we debottleneck? And that can be done by discrete simulation, identifying bottlenecks, taking a look, trying to be more cost effective, and looking at maybe surge capacities in between, or replacing it with new innovative technologies that are out there: battery electric, trolley assist, vertical conveyance systems, rail hauls. There's lots of different material handling systems out there that aren't ubiquitous yet, but they're all available, and we need to bring these online.
Well, look, thank you, Gary, for your time today. It's been illuminating. Today, I've been speaking with Gary Poxleitner, Principal Mining Engineer at SRK Consulting. I'm Dom Hale. Thanks for watching.